Don't forget to subscribe and ring that bell.
Boom, we're back with the 2018 Calc AB from College Board AP practice exam. We are going to do free response question number 5 as we continue section 2, part B. And oh my Lanta, we don't get to use a calculator. That's fine, because when we don't get the calculator, the algebra tends to be simpler. 4 was a little shaky, but 5, I'm sure will be fine. Let's start it. Number 5 reads, during a chemical reaction, the function y equals f of t models the amount of a substance present in grams at time t seconds. At the start of the reaction, t equals 0, there are 10 grams of the substance present. The function y equals f of t satisfies the differential equation dy dt equals negative 0.02 y squared. You know, normally I like some sort of table or chart or graph, and they don't give us one here, but whatever. I don't care. I'll still do this. A. Yeah, I'm bitter. A says, use the line tangent to the graph at y equals f of t and at t equals 0 to approximate the amount of the substance remaining at the time t equals 2. Two things we need to do. Line tangent to the graph, that tells me y minus y1 equals m times x minus x1. Anytime you need a line of a tangent or the equation of a tangent line, we always go to y minus y1 equals m times x minus x1. I said there were two things. That's the first. The second is, once I have that, I need to approximate the amount of substance remaining when t is 2. So I'm going to use that equation, okay, and put a 2 in for my x, or in this case, t, and figure out what it equals to. All right? What are the equals? What it equals, period, not what it equals to. Whatever. Let's just start this problem. All right, so when I need to come up with an equation of a line, I need three things. I need a coordinate, an x and a y, and then I need a slope, which is m, and slope is the same thing as derivative. So, what do we got here? All right, well, I think the only thing as far as points that I see in the write-up that they give us is that at time 0, there are 10 grams. Okay, so let's go back here. Let's pick this funky thing. Okay, so when time is 0, my substance present is 10. So that's kind of like my x and y. All right, so I'm going to put a 0 in for that x. 0, x minus 0. I'm going to put a 10 in for this y. All I need is my slope. Now remember, children, that slope, which is my m value, is the same thing as derivative. All right? They give us a derivative. The derivative of y with respect to t. The derivative of y with respect to t, because substances are y. Okay, so they say dy dt is negative 0.02 y squared. I mean, I suppose I can throw that in there, but let's clean this up. If I only knew what y was. Oh, yeah. Y is 10. Y is 10. Y is 10. So negative 0.02 times 10 squared. 10 squared is 100. 100 times negative 0.02 is, well, I just slide the decimal over twice. Negative 2. That's my slope. Okay? So that is going to go in for slope. Negative 2. All right, well, let's clean this up a little bit. We're going to have to find the y when x is 2. Remember, x and t are our same variable. T is the same thing as x in our equation, which they want at 2. So we have negative 2. This is, or Pretend I didn't write that. Negative 2 times x. All right, so y minus 10 equals negative 2 times x. I'm going to add 10 to both sides. So overall, my equation is y equals negative 2x plus 10. A 2 is going in there. Negative 2 times 2 is negative 4 plus 10. That gives me 6. And 6 is the answers, all right? They're not asking me to label it, but 6 would represent the grams present at a time of 2. All right, and what is time in minutes? It's in seconds at 2 seconds. They didn't ask us for that, but, you know, let's go above and beyond because we are cool, and that's what cool people do. You know, I think they realized how bitter I was that we didn't get a table or a graph or a chart, and they decided to throw one in here for B. Using the given differential equation. When they say the given differential equation, they are referring to this right here, differential equation, okay? So using this, let's just put this out there, negative 0.0002. We'll use this one. Ooh, let's change it to y squared, okay? So using this differential equation, determine whether this graph of f could resemble the following graph. Okay, discover the graph of f. Okay, I made a mistake. The graph of the original equation could resemble this following graph here. Okay, so could f be this? Okay, if this was the differential equation from it, and I say f, it really could y be this, given this dy, dt, whatever. You know, I don't like how they flip-flop back and forth, but it's the same thing. Okay, as long as you know what you're doing, there's really no math involved here. Why? Why is there no math involved here? It's just kind of logic. I guess it is math, but you're not doing calculations as far as major algebra here. This derivative or slope, right, because it's derivative, is always negative. How come? Whatever y is, I square it. So whenever I square something, it will always be positive. I am multiplying it times something that is negative. Whenever I multiply a negative times a positive, it should always be negative. Okay? If my slope is always negative, that means my graph will always be going down at some point, right? It will never be going up. Let's take a look at this right here, which they say, okay, could this be that graph? The answer is no. How come? Because even though this is negative, 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 boop, what happens to the rest of the graph? This is increasing. This is a positive derivative or a positive slope. Our slope should always be negative. That's why. So give a reason for your answer. Okay, now what I have, this gibberish on the left, isn't really necessary. What I'm about to write on the right side, the lower right side, is what's necessary. Starting here, you need to answer the question, and it's no. Okay, no. How come? Because we want to say something along the lines of the effect that the slope is always decreasing. Okay, the slope is always decreasing. I use these 3 dots to represent therefore. I saw it somewhere a long time ago. I don't even know if it's accurate. Therefore, okay, this graph has an increasing section. Okay, that's it. Okay, no, that's the answer. How come? Because the slope, based on my differential equation, is always decreasing. I don't even think I need therefore. That's just fancy. This graph has a section That's increasing. I don't know if you want to point to it, you can. That's fine. But you see what I'm saying? Like, look, I didn't need anything on the left. If I knew what I was doing, I just need what's in that box on the lower right-hand side, or in this case, it is now the middle right. Ooh, hoo, hoo. I am such a nerd because I love solving differential equations. It's terrible, but you know, that's what the good Lord gave me, the mind to do this stuff. C, find an expression for y equals f of t by solving the differential equation dy dt equals negative 0.02y squared. With the initial condition, f of 0 equals 10. All right, I know this is really a coordinate. X is 0, y is 10. So this is the initial condition. They're giving us two values because we are going to solve this and get a c. A constant is going to be in there at some point. And in order to solve for that constant, we're going to have to use that initial condition. But this is the type of problem where I need to break apart my y's and dy's so that they're on one side. And in this case, anything that's not a y, like a general number, and dt on the other side. And then I integrate both sides. So let's start with dy dt equals my negative 0.02y squared. The first thing I want to do is get this y squared from the right side to the left. So I'm going to multiply both sides by 1 over y squared. This goes bye-bye. 1 over y squared. All right? And, yeah, I could do it on the same step. So now I want to get this dt over to the other side. So I'm going to multiply the left side by dt. These cancel. And I'm going to multiply the right side by dt. Let's rewrite everything we have. We have 1 over y squared dy on the right side equals negative 0.02 dt on the right side. This is on the left. Did I say that's on the right side? That's on the left side. And negative 0.02 dt is on the right. At this point, I can now integrate both sides. Well, the right side is easy. Okay, this is just a number. When I integrate it, okay, the variable comes back. I mean, we can use an x, or we can use a t, because that's a dt. Negative 0.02 t. Okay, since there are no bounds, it's plus a constant. This integral evaluates to this right here. All right? Equals. Now, the left side, I'm going to change this up right here so it's easier to manipulate, okay, to actually integrate. I'm going to say, well, that's like doing the integration of y to the negative 2. I'm going to bring this up, dy. To me, that's easier to integrate. How so? I add 1 to this exponent and make it a negative 1, and then I divide by whatever that is. Okay, so I have y to the negative 1 divided by negative 1, which is negative y to the negative 1. Or in this case, let's clean it up more. That's over 1. Let's bring this down now so that exponent becomes positive. So I have negative 1 over y. But I'm missing, okay, let's do this to clean. Negative 1 over y. There's no bounds in this one either, so I still need a plus c. Now, those constants on the left and right side are different. Even though they're both c, I can say the one on the left is c1, and the one on the right is c2. Because maybe the constant on the left is 3. Maybe the constant on the right is negative 7. I don't know. Maybe they're the same. Maybe they're not. All right? So what I need to do is let's isolate this y. Let's make it so there's one constant. Okay? Let me see. Can I move this over here? Can I move this over here? Can I move this over here? Good. Let's do the following. Let's subtract c1 and subtract c1. Negative 1 over y equals negative 0.02t plus. If I have a constant and I take away another constant, it's still going to remain a constant. Okay? So, I am going to do a little trick here. I'm going to do a little trick here. Oh, yeah, I see what I did there. I multiplied both sides by -1. So that's going to be, oh, that's dirty what I did there. But we'll do it anyways. All right. I want to get this positive, this side. So I want to multiply by -1. Multiply this side by -1. And before I do that, I should flip that before I do that too. See, I'm debating whether I should flip it or not. I should end up with the same thing. I should end up with the same thing. Okay. Let me flip it first. I'm going to flip this first. Here's my little, I like doing this. It makes sense here. I can flip this. This side is over 1. I can flip both sides and it maintains its equivalence. So I can say y over -1 equals 1 over -0.02t plus c. Okay? I'm going to do that because I want to get the y alone in this case because it's going to be easier to solve for it. And then now I'm going to multiply both sides by -1. And it gets rid of this. And I multiply this side by -1. And I now have, yeah, that I think is an easier way. I got y equals -1 times -1 is -1 over -0.02t plus c. I think that's the easiest way to do this. Now, that would be my equation, except I need a c value. Okay? I can't just leave a c in there. I need an actual equation. This is where my, it's bored. I can't wait till we get the new ones. Okay? My initial condition comes into play. When x is 0, y is 10. Okay? In this case, x is the same thing as t. When it's 0, y is 10. All right? So I can plug in for a t and a y, and now I can solve for c. Now it becomes really easy. All right? It becomes easier because we're only going to have one unknown. So 10 equals -1 over -0.02, and t, or x, is actually 0 plus c. Okay, man, okay. All right, so I'm going to do this. This goes, this board. Anytime I multiply something times 0, goes bye-bye, and I changed to black, goes bye-bye. So 10 equals -1 over c. And again, I can flip these, right? This is technically over 1. So I can say c over -1 equals 1 over 10, and then multiply both sides by -1. So -1/10, yep, I'll be okay. -1/10, which is -0.1, equals c. All right? This is what my c value is. This is going to go back in here for me to solve. Oh, should I multiply all these by 10? Is that what I get? No. For me to get this equation. Okay, this is now going to be y equals -1 over -0.02t plus c. It's plus a -0.1, so I'm just saying -0.1. Okay, this is a legit answer. Now, if you happen to get your hands on an answer key to check your work, and you just didn't understand how to do it, so you came here, the answer key looks very different. The answer key looks like this. The answer key looks like 50 over t plus 5. Because what they end up doing is, they don't like decimals and fractions, so they multiplied everything times -50. In fact, they canceled out a negative from everywhere. They made it positive, okay? So what they did is they took this and they canceled a -1 out of everything. Okay, so every negative is going to flip. So it's 1 over 0.02t plus 0.1. And now they're like, well, let's get rid of these decimals. In order to make this into a 1, this one right here, we need to multiply that times 50. So we're just going to multiply everything times 50. That's times 50, this is times 50, and this is times 50. And what you get here is the numerator is now 50 over 50 times 0.02 is 1, so I got 1t, plus 0.1 times 50 is 5. So that's how they got their answer there. So if I would have left it like I did initially right here, you would have said it doesn't match. I mean, some of you would have gotten it, but some of you might not. Well, yeah, take the negative out, make everything positive, and then multiply everything times 50, and you will get what's on the answer key right there. The fourth and final part of question 5D, says, determine the amount of substance. Determine whether the amount of substance is changing at an increasing or a decreasing rate. Explain your reasoning. Oh my God, friends, we need to explain. We need to explain that, Lucy, and we need to use some words, okay? So the amount of substance is changing at an increasing or decreasing rate. Be very careful in two spots here, okay? This isn't that difficult of a problem if you are careful, not with your math, but with your understanding. Is it changing at an increasing or decreasing rate? So is the change increasing or decreasing? I don't want the first derivative, I want the second derivative, because this increasing or decreasing rate, okay, is the rate changing? Okay, that means I take the rate that they gave me initially, okay, this is initially in the problem, all right, and that is the first derivative, dy. That's the first derivative of y. That's the rate. That's the rate that they're asking about right here, okay? Is that increasing or decreasing? So I need to take the derivative of this, okay? Which means I need the second derivative of y with respect to t, okay? Let's take the derivative of it. So that's the first thing you need to be careful with, okay? Now, this isn't a difficult thing to do, not at all, okay? The 2 comes down, I multiply, so it's negative 0.04 or negative 0.04. I know I always put a 0 in front most of the times, but sometimes I do get lazy. And then y, then I subtract 1, so it's y to the 1. But we need to do this implicitly. Every time we take the derivative of the y, we need to write dy dt next to it, okay? Now, what is dy dt? They give us dy dt here. I've got to substitute this value in for dy dt. Okay, so let's scroll down here. So you have negative 0.04y times negative 0.02 y squared. All right, well, y, let's go here, y times y squared is y cubed. 2 times 4 is 8, and we have how many decimal places? 1, 2, 3, 4. So we have 1, 2, 3, 4. 0, 0, 0. And it's positive because a negative times a negative is positive. Okay, so this right here, and if you want to put a 0 out front, you can. A positive 0.0008 y cubed, that's the second derivative right here. But they're not asking us what is the second derivative. They're asking us, does that represent an increasing or decreasing rate? Now, you might say it's positive, it's increasing, because it's positive. You'd be half right. This is the point. This is the second place you need to be careful. I guess looking back, it might be the third place. The first place might be in the wording of the problem, to know that you're going to need the second derivative. The second place, you need to make sure that, don't forget to write dy dx next to your y. Okay? But the third thing has to do with this y value right here in your explanation. Okay? In part 5C, We literally came up with the answer that y equals, what was it on the answer key? 50 over t plus 5. Okay? Well, what if this is a negative value, right? If that's a negative value, I end up with a negative y, which would make this expression negative. But guess what? T is time. Time, the initial condition, way back when this problem started. So when time was 0, there was how many? It was like 10 grams of substance in there, right? This is where we start, and we just move forward. This value will always be positive, which means what? If t is always positive, y will always be positive. And that is the reason why this will always be positive. If y is always positive, then y cubed is always positive, which means this positive y cubed times a positive decimal will always result in a positive number. So in my explanation, okay, in the question, they asked us, is it changing at an increasing or decreasing rate? Let's answer that. It's increasing. Bam! I'm sure they don't appreciate the exclamation points. You could just say increasing. I just like to be, you know, dramatic. Okay, it's increasing, but explain. Use your words. Since y is always greater than 0, I like using inequalities instead of words if I can. Since y is always greater than 0, the rate is always changing. And notice I'm using their words. Yep, changing, not change. Changing at an increasing rate. That is the explanation you need. That is the answer to the problem. And that, my friends, is a wrap. Boom! For free response question number 5. We are done. I know you want to come back for free response question 6. I just know it. I feel it right in my heart. Don't forget to follow me, like, subscribe, do whatever. Leave a comment if there's a test you want to see. I'd do it. I don't care. I'm crazy like that. I do it all. Okay? I will see you for the next video for free response question 6. Bye-bye.
Don't forget to subscribe and ring that bell.